A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
My Weird Prompts is a community-driven initiative exploring how AI can fuel curiosity and uncover the fascinating ways our world works. GPU compute for this podcast is generously provided by Modal. Learn more at modal.com.
So, you are sitting on a goldmine of data in your production database, but the moment you try to move it into a data lake for analysis, you realize you are actually sitting on a pile of digital plutonium. That is the paradox we are looking at today. How do you extract the value without the radioactive fallout of a privacy breach?
It really is the classic data engineer's dilemma, corn. Herman Poppleberry here, and I have been looking forward to this one because our housemate Daniel sent us a prompt that gets right into the weeds of how we actually bridge that gap between useful insights and legal liability. We are recording this on March 15th, 2026, and the landscape of data privacy has shifted dramatically even in just the last few months.
It is funny you call it digital plutonium, because once that personally identifiable information, or PII, leaks into your analytical layers, it is incredibly hard to clean up. It is not just about a single table anymore. It is in the logs, it is in the downstream models, it is in your backups, it is everywhere. And with the new regulations we are seeing this year, the cost of that cleanup is not just a technical debt problem, it is a survival problem for the business.
And Daniel was asking specifically about the technical architecture of these redaction pipelines. We are moving past the days where you just run a few SQL scripts to mask a column. We are talking about sophisticated context-aware systems that handle the transition from production to analysis in real time. We are moving toward what the industry is calling machine-readable privacy orchestration.
Right, because the goal isn't just to hide the data, it is to maintain the utility of the data while removing the risk. If you just blank out everything, you might as well not have a data lake at all. You cannot run a trend analysis on a bunch of no values. So, let us start with this idea of the anonymization gap. What are we actually talking about when we say we are moving from production to the analytical layer?
The gap is essentially the delta between your raw operational data, which needs names, addresses, and credit card numbers to actually function, and your analytical data, which really just needs the patterns. In production, you need to know that John Doe lived at 123 Main Street to ship him a package. That is a functional requirement. But in the data lake, you just need to know that a person in that specific zip code bought a specific type of product at a specific time. The problem is that the process of moving that data, the ETL or ELT process, is often where the most dangerous leakages happen because we tend to treat the analytical layer as a trusted zone, when in reality it is often the most exposed.
And I think what a lot of people miss is that simple masking or hashing is not the same thing as true anonymization. We actually touched on some of the basic database level security back in episode 1123 when we were talking about the future of Postgres. We mentioned things like the PG crypto extension for basic masking. But as we discussed then, that kind of approach fails once you hit a certain scale or complexity. It is too static.
It really does fail, and it fails in ways that are often invisible until it is too late. Hashing is a great example of what people get wrong. If you hash a phone number using SHA-256, you have not anonymized it, you have pseudonymized it. If I have a list of all possible phone numbers, which is a finite and relatively small set, I can just hash all of them using the same algorithm and do a reverse lookup. It is a deterministic mapping. If the hash is the same every time, the identity is still there, just wearing a mask. True anonymization in 2026 requires something much more robust, especially with the new standards we are seeing from organizations like NIST.
That is a great point. I was actually reading through the February 2026 update to the NIST Privacy Framework, specifically Special Publication 800-226. They have really leaned into the idea that automated redaction standards need to account for what they call quasi-identifiers. These are pieces of information that are not PII on their own, like a birth date, a gender, or a zip code. But when combined, they can re-identify someone with startling accuracy.
Oh, the quasi-identifier problem is massive, and it is the bane of every data scientist's existence. There is that famous study from Harvard showing that 87% of the United States population can be uniquely identified using only their 5-digit zip code, gender, and date of birth. So, if your redaction pipeline leaves those three things in the clear, because they are not technically PII under a strict definition, you have not actually protected anyone. You have just made it slightly more annoying for an attacker to unmask your users. This is why the pipeline architecture itself has to be so much more than just a set of rules. It has to be an intelligent interceptor that understands context.
So let us get into that architecture. If I am building a pipeline today to move data from my production SQL environment into something like Snowflake or a massive S3 data lake, where does the redaction actually happen? Do I do it in the source, in flight, or once it hits the destination?
Ideally, you want to do it as early as possible in the ingestion flow. You want to intercept the data before it ever touches the analytical storage. This is the shift from traditional ETL, extract transform load, to a more privacy-first streaming interceptor. If you wait until the data is in the warehouse to redact it, you have already created a massive surface area for a breach. In fact, recent statistics from the 2025 Data Breach Investigations Report show that over 60% of data breaches in analytical environments are caused by overprivileged access to unmasked data that was sitting there waiting to be processed. That is data that should have been redacted the moment it left the production boundary.
That is a staggering number. 60%. It means we are basically leaving the front door open while we decide what color to paint the walls. So, if I am building this interceptor, how does it handle things like referential integrity? Because this is the big technical hurdle. If I redact a user ID in the orders table, but I do not redact it the exact same way in the transactions table, my analysts cannot join those tables anymore. The data becomes a series of isolated islands, and the data lake becomes a data graveyard.
That is where tokenization services come in, and it is a much more sophisticated approach than simple hashing. A tokenization service replaces a sensitive value with a non-sensitive equivalent, a token, but it maintains a secure, encrypted mapping table behind a very heavy virtual vault. If the pipeline sees user ID 12345, it asks the tokenization service for a token. It gets back something like Blue Rabbit 99. Every time that user ID appears in any table across the entire pipeline, it gets replaced by Blue Rabbit 99. This is called deterministic tokenization.
So the analysts can still see that the same person made 10 different purchases, and they can see the relationship between the orders and the transactions, but they have no idea who that person actually is. And if a developer or a support person genuinely needs to re-identify that user for a specific audited reason, like a legal request or a critical bug fix, they can theoretically go to that vault and map it back.
But that vault is the most protected piece of infrastructure in the entire company. It is not just sitting in the database. It is often a separate service entirely, using something like HashiCorp Vault or a cloud-native equivalent with strict identity and access management and full audit logging. This allows you to have that referential integrity without the risk of the raw data being scattered across 20 different analytical tables. You are centralizing the risk into one highly fortified location instead of spreading it thin across your entire infrastructure.
Okay, so that handles structured data, like columns in a database where we know exactly what we are looking at. But what about the messy stuff? Daniel mentioned that this is particularly relevant for things like feedback loops and anonymous applications. That usually involves free text fields, customer support logs, or even chat transcripts. You cannot just use a tokenization service on a paragraph of text where a customer might have typed, "Hey, my name is Herman Bubbleberry and I live in Jerusalem."
That is the real frontier of PII redaction right now. That is where we move from simple rules-based systems to NER, or named entity recognition. If you try to use regular expressions or regex to find PII in free text, you're going to have a bad time. Regex is great for finding a credit card number because it follows a very specific pattern, like the Loon algorithm. But how do you write a regex for a name, or an address that might be formatted in 100 different ways depending on the country? You end up with a regex that is 10,000 lines long and still misses half the cases.
Right, and even worse, how do you handle the ambiguity? If a customer writes, "I bought an apple yesterday," are they talking about the company, the fruit, or did they accidentally capitalize a person named Apple? A regex is going to flag that every time, or worse, miss it every time. This is where we need the AI to actually understand the sentence structure.
Precisely. This is why we are seeing a massive move toward transformer-based NER models for these pipelines. Tools like Microsoft Presidio have become the industry standard here. Presidio is an open source framework that essentially acts as an orchestration layer for PII detection. It uses a combination of different models. Some are spacey based, some are transformers like BERT or Robert, and it even uses some sophisticated logic to verify the findings. It does not just look at the word, it looks at the context around the word. If it sees a capitalized word preceded by the phrase, "my name is," the probability of it being a name skyrockets.
I have looked into Presidio, and what I find interesting is how it handles the confidence scores. It does not just say, "this is a name." It says, "I am 85% sure this is a name." And as a pipeline architect, you can set your threshold. If you are in a highly regulated industry like healthcare or finance, you might set your threshold very low to be extra safe, even if it means more false positives. But that leads to another problem, doesn't it?
It really does, and that is a huge trade-off. If you are too aggressive with your redaction, you end up with what we call the Swiss cheese problem. You look at a customer feedback log and it just says, "Hello, REDACTED. I am having trouble with my REDACTED in REDACTED." At that point, the data is useless for sentiment analysis or product improvement. You have destroyed the utility in the name of privacy. You cannot tell if the customer is complaining about a broken phone in Chicago or a late pizza in London.
It is a delicate balance. I think back to episode 1219 where we talked about mastering structured AI outputs. We discussed how critical it is to ensure that the output of an LLM follows a strict schema. The same principle applies here. If your redaction pipeline is spitting out unstructured, messy text with random tags, it is going to break every downstream analytical tool you have. You need that redaction to be as clean and predictable as the input was. You need to maintain the grammar and the flow so that your downstream NLP models can still function.
And that leads us into the technical robustness of these tools. Because, while a transformer-based model is light years ahead of a regex, it is still not perfect. These models have edge cases that can be really dangerous. For instance, think about internationalization. Most of these NER models are trained heavily on Western data. If you feed them a name from a culture they haven't seen much of, or an address format from a smaller country, the accuracy drops off a cliff. I have seen models that perfectly redact every John Smith but completely miss names in kanji or Cyrillic.
That is a massive point. If you are a global company and your redaction pipeline only works for English names and United States addresses, you are effectively leaving your international users' data exposed. You are creating a two-tier privacy system, which is a massive legal liability under things like the GDPR or the newer Global Privacy Accords. This is why you cannot just set and forget these models. You have to treat them like any other critical piece of machine learning infrastructure. You need continuous monitoring, you need a feedback loop where humans can review flagged items, and you need to be constantly retraining on your specific data distribution.
And that is where the latency trade-off comes in. Running a full transformer model for every single log line that enters your data lake is computationally expensive. If you are processing terabytes of data a day, the cost of the GPS to run that inference can actually start to rival the cost of your entire data warehouse. We are talking about adding milliseconds or even seconds of latency to your data ingestion. For a real-time feedback loop, that might be unacceptable.
So, how are teams handling that? Are they sampling the data, or are they finding ways to optimize the models? Because you cannot just ignore the cost.
It is a mix of both. We are seeing a lot of interest in distilled models like DistillBERT or even smaller models like Phi3, which can give you 95% of the accuracy with a fraction of the latency. But we are also seeing more intelligent pipeline routing. You might use a very fast, cheap model or even a high-quality regex to do a first pass. If it finds something suspicious, it routes that specific chunk of text to the heavy-duty transformer model for a final verdict. It is about being smart with your compute resources. You do not use a sledgehammer to crack a nut, but you keep the sledgehammer ready for the tough shells.
That makes a lot of sense. Use the cheap tools for the easy stuff and save the expensive AI for the nuances. But even with the best tools, we have to talk about the second-order effects. If I am a data scientist and I am trying to train a machine learning model on this redacted data, how much is the redaction itself skewing my results? This is something I think a lot of people overlook.
This is a huge concern in the research community right now. It is often called the utility versus privacy trade-off. If your redaction pipeline consistently removes certain types of information, it can introduce significant bias into your downstream models. For example, if your NER model is better at identifying and redacting names from certain ethnic backgrounds than others, your training data is no longer a representative sample of your actual user base. You might accidentally be training your churn model to only understand one demographic because the others have been over-redacted or under-redacted.
Wow, I had not even thought about that. So the privacy tool itself becomes a source of algorithmic bias. That is a nightmare for compliance and ethics. You are trying to do the right thing by protecting privacy, but in doing so, you are making your AI less fair and less accurate.
It really is. And it is not just about bias, it is about the loss of context. If I am trying to build a churn prediction model and the redaction pipeline has removed all the geographic data because it was worried about address leakage, I might lose the most important predictor of churn, which could be a regional service outage. You are effectively blinding your models to certain realities. This is why some teams are moving toward differential privacy, where you add a mathematically calculated amount of noise to the data instead of just redacting it. It allows for aggregate analysis while protecting individual identities.
So what is the alternative? Daniel's prompt mentioned moving data to analytical layers for anonymous applications. Is there a way to do this without traditional redaction? Is there a way to get the insights without the plutonium?
Well, the big trend we are seeing for 2026 is the rise of synthetic data. Instead of trying to redact your real data, you use your real data to train a generative model like a GAN or a specialized transformer that can create entirely new synthetic datasets. These synthetic datasets have the same statistical properties as the original data, but none of the actual PII. There are no real names, no real addresses, just statistically accurate representations of them. If your real data shows a correlation between zip code and purchase price, the synthetic data will show that same correlation, but with fake zip codes and fake people.
That sounds like the holy grail. But how do you ensure the synthetic data is actually accurate? If I am running a complex analysis on customer behavior, can I really trust a dataset that was essentially made up by another AI? It feels like we are adding another layer of abstraction that could hide the truth.
That is the million-dollar question. For certain types of analysis, like testing a new database schema or building a basic dashboard, synthetic data is perfect. But for deep predictive modeling, we are still finding that nothing beats the real thing. There is a risk of the synthetic model failing to capture the long-tail outliers, which are often the most important parts of the data. So, most high-performing teams are still relying on very sophisticated redaction pipelines as their primary defense, with synthetic data used for development and testing environments.
Okay, so let us talk about the tooling landscape for a minute. We mentioned Microsoft Presidio, but what else is out there? If I'm an AWS shop or a Google Cloud shop, what are my options? I assume they have built-in services for this by now.
They definitely do. AWS has Glue Data Brew, which has built-in PII detection and masking. It is very convenient if you are already in the AWS ecosystem because it integrates directly with S3 and Redshift. It uses their Amazon Comprehend service under the hood for the NER part. Google Cloud has their DLP, Data Loss Prevention, API, which is incredibly powerful. It can handle everything from text to images. If someone uploads a photo of their driver's license to a support chat, the Google DLP, AP, I can actually use OCR to find the text in that image and redact it before it ever gets stored.
That is impressive. I think we often forget about images and PDFs when we talk about PII. People scan their documents all the time and send them to companies. If those are sitting unredacted in an S3 bucket, that is a massive liability. It is not just about the SQL tables.
It is. And then there is the custom route. A lot of teams are using tools like dbt, the data build tool, to build their own redaction macros. This allows them to define their redaction logic once in Jinja and apply it across their entire warehouse. It is great for structured data because it is version controlled and transparent, but again, it struggles with that unstructured free text problem. You cannot really run a transformer model inside a standard SQL query without some serious external function calls, which brings us back to the latency and cost issues.
I like the dbt approach for its transparency. You can see exactly how the data is being transformed in your Git history. But as you said, it is only as good as the logic you give it. If your macro doesn't account for a new type of PII, like a new digital wallet ID or a crypto address, you are back to square one. You need a way to keep those definitions updated.
Right. And we should also mention the importance of auditing these tools. You cannot just trust that AWS or Microsoft is catching everything. You need to be running regular penetration tests on your own data lake. You should be intentionally trying to re-identify individuals in your redacted datasets to see where the holes are. We call this a re-identification attack simulation. If a junior analyst with a bit of Python knowledge can unmask a user by joining your redacted table with a public dataset, then your pipeline is broken.
It is like a red team exercise for data privacy. I think that is a brilliant idea. If you can re-identify a user, you know your pipeline is broken. It is a much better test than just looking at a few rows and saying, yep, that looks redacted. You have to actually try to break it.
And you have to do it constantly because the techniques for re-identification are getting better every day. With the amount of leaked data already out there on the dark web, it is becoming easier and easier to join an anonymous dataset with a leaked one to unmask people. This is why the bar for what counts as anonymized is constantly moving higher. What was considered safe in 2022 is definitely not safe in 2026.
It really underscores the point that privacy is not a feature you add at the end of a project. It has to be baked into the very architecture of how data moves through your organization. If you are not thinking about redaction at the ingestion layer, you are already behind. You are just building up a massive liability that will eventually come due.
You really are. And I think that leads us perfectly into some of the practical takeaways for anyone who is actually building these systems. Because it can feel overwhelming, but there are some very clear steps you can take to get this right. It is about moving from a reactive posture to a proactive one.
Yeah, let us break those down. What is the first thing a team should do if they realize their analytical layer is currently a PII nightmare? Where do they start?
The first step is to implement privacy by design at the ingestion layer. Stop the bleeding. Before you try to clean up the existing data lake, make sure that no new PII is entering it. Set up that interceptor, whether it is a streaming service like Kafka or a pre-warehouse processing step in your ELT flow. Use a tool like Presidio or a cloud-native DLP service to start flagging and redacting data as it arrives. You have to close the tap before you can mop the floor.
And I would add to that, do not just delete the data. Use a tokenization service. Give your analysts a way to maintain referential integrity. If you just strip out all the identifiers, your data scientists are going to revolt because they won't be able to do their jobs. You need to give them a safe way to join tables without seeing the raw PII. A happy data scientist is a productive data scientist, and you do not want them trying to bypass your security measures just to get their work done.
That is crucial. Shadow IT is the enemy of privacy. And the third thing is to maintain that secure encrypted mapping table, but keep it in a completely separate security domain. Use the principle of least privilege. Only a handful of people should ever have the ability to trigger a re-identification, and every single time they do, it should be logged, reviewed, and justified. It should be a break glass procedure, not a daily occurrence.
I also think the point about auditing your NER models is huge. Do not assume that because you are using a transformer model, you are 100% safe. Run your own benchmarks. Test it against your specific data. If you are a fintech company, make sure your model knows what a Swift code or an IBAN looks like. If you are in healthcare, make sure it understands the nuances of medical record numbers and HIPAA requirements. You have to train the model on your specific reality.
And finally, stay informed about the changing regulatory landscape. The NIST framework update from February 2026 is just the beginning. We are seeing more and more jurisdictions move toward very strict definitions of what constitutes anonymization. If you are not automating your redaction now, you are going to be scrambling when the next big privacy law hits. The era of manual redaction is over.
It really is a race against time, isn't it? The data is growing faster than our ability to protect it. But with the right tools and the right architecture, it is possible to have your cake and eat it too. You can get those deep insights. You can build those feedback loops, and you can improve your products without compromising your users' trust.
It is a challenge, but it is one of the most important ones we have in the tech industry today. Trust is the most valuable currency we have, and once you lose it through a data breach, it is almost impossible to get back. People will forgive a bug, but they won't forgive you for leaking their home address and credit card history.
Well said, Herman. I think we have covered a lot of ground here, from the anonymization gap to the nuances of NER models and the future of synthetic data. It is a complex topic, but hopefully this gives our listeners a solid framework for thinking about their own data pipelines.
I hope so too. It was a great prompt from Daniel. It really pushed us to look at the intersection of engineering and ethics, which is where the most interesting stuff usually happens. It is not just about the code, it is about the impact of that code on real people.
Definitely. And before we wrap up, I want to say a huge thank you to everyone who has been listening and supporting the show. We've been doing this for over 1,200 episodes now, and the community feedback is what keeps us going. We love getting these technical prompts that make us dig deep.
It really does. If you are enjoying the show, we would really appreciate it if you could leave us a quick review on your podcast app or on Spotify. It genuinely helps other people find the show and helps us grow the community. We are trying to reach as many data engineers and privacy advocates as possible.
Yeah, it makes a big difference. And if you want to stay up to date with everything we are doing, head over to our website at myweirdprompts.com. You can find our RSS feed there, plus all the different ways to subscribe. We also have a Telegram channel if you search for My Weird Prompts, where we post every time a new episode drops.
It is the best way to make sure you never miss an exploration. We have a lot more interesting topics lined up for the coming weeks, including a deep dive into decentralized identity, so definitely stay tuned.
Alright, that is going to do it for us today. Thanks for joining us for another deep dive.
This has been My Weird Prompts. We will see you next time.
So, Herman, I have to ask, since we are talking about redaction, if you had to redact one thing from your own personal history, what would it be?
Oh, that is easy. That phase in the early 2000s where I thought wearing 2 polo shirts with both collars popped was a good look. That definitely needs to be scrubbed from the record. There is no utility in that data.
See, I think that is a quasi-identifier. It tells me everything I need to know about your teenage years. You cannot redact that. It is part of the statistical distribution of your life. It provides context for your current obsession with data integrity.
Fair point. I guess I will just have to live with the high confidence score on that one. It is a permanent part of my metadata.
Anyway, thanks for listening, everyone. We will catch you in the next one.
Take care, everybody.
One last thing. I was thinking about the synthetic data point you made. Imagine if we could create a synthetic version of our podcast, where we never made any mistakes and always had the perfect analogies.
That sounds incredibly boring, Corn. People listen for the popped collars and the digital plutonium references. The imperfections are the utility. If we were perfect, we would just be another AI-generated newsfeed.
You know what? You are absolutely right. The noise is part of the signal. Our quirks are what make the data valuable.
All right, let us get out of here before we start getting too philosophical about our own existence.
Agreed. Bye, everyone.
Goodbye.
And remember, if you are looking for those past episodes we mentioned, like the one on Postgres or structured AI outputs, you can find them all at myweirdprompts.com. The archive is fully searchable, so you can dive as deep as you want into any of these topics.
We have got over 1,000 episodes in there, so there is plenty to explore. Happy hunting.
All right, for real this time. We're out.
See ya.
This really is a fascinating area. I was just thinking about the February 2026 NIST update again. The way they talk about automated redaction standards, it is almost like they are treating the redaction pipeline as a legal entity in itself.
It is moving that way. Responsibility is shifting from the person who made the mistake to the system that allowed the mistake to happen. It is a subtle but important shift in how we think about accountability in tech. We are building systems that have to be legally compliant by design.
It really is. It makes the engineering even more high stakes. But that is why we love it, right? The challenge of building something that is both powerful and safe.
Right. The stakes are what make it interesting. If it were easy, everyone would be doing it perfectly.
Okay, I think we have officially hit every point on the list. Thanks again to Daniel for the prompt. It was a good one.
It definitely was. All right, let us go see what is for dinner. I think it is your turn to cook corn.
Is it? I might have to redact that from my memory. I am pretty sure I cooked last night.
Nice try. No masking allowed in this house. I have the logs to prove it.
Worth a shot. See you guys.
Bye.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox.
Thanks for listening to our show, my weird prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. My weird prompts.